Good afternoon, everyone. Welcome to our SAIMM event. My name is Elias Matinde, and I'll be chairing this session. Behind the scenes, I've got other committee members and also other panelists. I've got Butle, Kakalashe, John, I've got Camilla and Tim. So we will be hosting you for the next 1 hour, where we will be discussing about the future of rare earths in South Africa. My name is Elias Matinde, like I said, and the motivation for this event is to discuss or to brainstorm on how best we can maximize the value chain optimization in terms of rare earths production in Southern Africa. Not only in South Africa, but we're looking at all the rare earths deposits in Southern Africa. And I would like to introduce one of our panelists, Dr. Niels Beck, so I can't pronounce that properly. Unfortunately, Niels could not be with us this afternoon. He could not attend in person, but he sent in a presentation. And Camilla, just an icebreaker, can you load that presentation up for us, please?
Sure, it is.
Okay, well, as Camilla is loading, I think you have received the agenda for this afternoon. It's not a lecture. We really want to discuss. Let's make it as open and engaging as much as possible. We want to look at or discuss really what are the barriers to value chain maximization in Southern Africa. What can we do to maximize the value? And what sort of capabilities do we need? What sort of synergies, regional, international? So we'll talk a little bit more on what we need to look at in terms after Niels' presentation. Okay, so this is Niels. Niels is an analyst at Roskill. It's now Wood Mackenzie. Yeah, it was acquired by Wood Mackenzie, and he specializes in rare earths. And you can see from his presentation, he's talking about the outlook to 2030, okay? And the rare earths industry in terms of, the applications and everything are in his presentation. So let me not preempt his presentation. And Camilla, can you play the presentation for us, please?
Hi, thank you for the introduction, and sorry that I can't be with you live today, but I very much look forward to joining you all in further discussions as well as the Rare Earths event in October. My name is Niels Bakkerberg. I manage Roskill Steel Alloys Division. We are, as of recently, a Wood Mackenzie business, and it's my pleasure to talk to you a little bit about rare earths and the research that we've been doing. And yeah, open to any questions. Please do get in touch with me, niels@roskill.com. I'm based down here in Cape Town, and I'm happy to chat to you about any questions you may have. So I'm just going to put up one slide here for you today, and apologize for sort of the information heavy slide, but I'd like to just use this as a base of the discussion for today, and use this as sort of effectively showing a unified graph that's all the interesting things of rare earths in in 3 figures here. So I've got as a tagline here, without rare earths, lithium-ion batteries are just expensive energy storage systems on wheels, right? And so we've seen the whole electrification movement and the interest in lithium-ion batteries for electric vehicles over the past few years. And one of the key things that has come hand in hand with this is the fact that the most efficient way to convert that energy into motion is through a neodymium iron boron magnet in a direct drive motor. There are various technologies out there, but in terms of producing the most energy or the most bang for your buck in a magnet, rare earths have taken that place. And why this is so critically important is because batteries are an expensive supply chain. So electric vehicles aren't a cheap solution to the automotive industry, but it's really one that's been spurred on by government incentives and part of the climate change narrative. So while originally the demand side was driven more by incentives starting in China, it's really becoming a consumer-driven market now. And in order for automotive makers to reduce the cost of the battery, they want to get as much out of these batteries as possible. And so with that, there is this focus on the rare earths magnets. So it doesn't matter what battery technologies we're looking at currently, when we're looking at the motor technology, that's where we find rare earths. Even if you're changing from one lithium ion batteries to nickel metal hydrides, such as the Toyota Prius, they themselves are looking to convert to lithium-ion batteries. Those markets, or hydrogen fuel cells. Depending on where the energy comes from, converting that into motion. This is again pointing at magnets. And so what we've seen in the rare earths industry is a sort of shift in the focus of demand. So on the left here, I'm showing you sort of the different groupings of your lanthanum and cerium, NdPr, neodymium, praseodymium, yttrium, and then your seg, samarium, europium, and gadolinium, and then also your heavy rare earth baskets, effectively. And so this is a figure that I've redacted a bit of information from our annual report, but showing you the two major applications, catalysts and magnets. And it's only over the last 5 years that magnets has actually overtaken catalysts as the primary demand market for rare earths. And this is where we're starting to see a lot of reshaping of those markets. Whereas catalysts distinct focus on lanthanum and cerium, both in catalytic converters as well as refining catalysts. In there, it's the magnets, the neodymium iron boron magnets, NdFeB, that are really taking that demand market. And so what I'm trying to show here now on the right, looking to the top right figure, is trying to visualize all of the elements together in their supply and demand markets, and also our forecasts at the bottom. So what this graph is showing you is really just supply divided by demand as a ratio. So if it's above 100%, you're in deficit, and below it's in surplus. And why this is quite a nice way to look at rare earths is because when we're mining for these commodities out of the ground, you're mining them as a package. And this is really one of the unique aspects of the rare earths. And as you can see on the left, there are various different applications for all of the different elements, and all of the different elements have a different suite of applications and scale. And this is why this is quite complex, right? So what we're seeing here is there was a large amount of surplus of all of the rare earths, and there was the narratives about illegal mining, and then there's been sort of cutting down of that in China, and that's really tightened the market. But at the same time, the demand has started to increase out of these permanent magnets, and there's been a focus towards neodymium consumption because of that, right? As I've mentioned, magnets are now the largest application for rare earths. And because of that, the supply and demand ratio of all of these industries are different. So you can see here that actually neodymium moved into a bit of a deficit in 2020. And this is because of that continued growth in batteries and electric vehicles requiring those rare earth magnets. Now, looking forward, we expect to see continued focus on rare earth consumption in magnets. And with the way the automotive industry is going, there's going to be a slight decline potentially in catalyst demand for rare earths. But even without that, the focus on magnets is really what's going to drive the overall narrative here. And as I said, when you mine for one of the rare earths, you're going to get the full suite. And because neodymium, in terms of its availability, is much lower than lanthanum and cerium, there's going to be a focus on neodymium markets, and we're going to see more lanthanum and cerium come onto the market. So if we're looking at the figure at the bottom, this is the forecast we're saying from 2020 through to 2030. So the market we expect to remain relatively tight around neodymium, because that's going to be the main driver of the industry at the moment. It's currently a bit of deficit, but we're seeing supply coming online to really manage that gap. And then longer term, this is sort of incentive for supply to come online and meet that growing EV market. But because the focus is on the relatively lower volume neodymium element, you can see here the surplus of lanthanum and cerium as well really increasing in the short term. There is some use of cerium in low-grade magnets, and that sort of flattens that off. And in lanthanum, you also have the replacement of nickel metal hydride batteries, such as the Prius switching to lithium ion. So there's some market loss in there as well. But really, so the fundamentals that we're seeing is this drive for neodymium Praseodymium also tightening up, but relative to the market staying in balance. And then each of these markets have their own sort of narrative in there. So I mentioned here you've got your SEG group, your samarium, europium, gadolinium. These elements sort of come together also as a package. So in the separation process, these get separated out. And now gadolinium has really taken some of the value requirements for separation of these elements over the period. So you can see here europium, if we go back to the top right figure, europium in terms of its surplus has increased. And this is largely related to decline in demand, sort of longer term over the last 15 years, and gadolinium tightening up here. And gadolinium, again, is used in other magnetic applications, and again, seeing some good growth in here. And because these are separated out together, if you look at the price series for europium, samarium, europium, gadolinium, the requirement to separate out gadolinium has needed to account in terms of its price. And so we're seeing similar price movements focusing around these elements. And so as we move forward, the requirements and the prices for these elements will have to reflect those demand markets. So lanthanum and cerium, high surplus, it's not the focus of demand, and we've seen their prices drop significantly, whereas praseodymium and neodymium have really seen a strong increase recently. Right, and this is again a change to what we've seen historically in the behavior of the prices, where prices tend to move quite in unison in terms of their long-term pattern, but recently it's really a demand focus, and that is because the demand balance for all of these materials is moving to a lot larger imbalance relative to the natural supply ratio. And that's effectively what we're trying to show here. So all of these markets, back to the bottom graph, these arrows showing you what's happening in terms of the fundamental driver related to supply around neodymium. And dysprosium, again, also being quite tight, a key element used in EV motors where there's a higher temperature application, so requirements of these heavy rare earths. So these materials also seeing a tightening of the markets. And you can see here in terms of some of the more heavy rare earths, unique or niche applications, and we'll have to see supply and demand account for some of that moving forward. Right, so that really sets the scene for what we expect to be happening over the next decade. Right, so just to recap quickly for you, so the focus is on neodymium in terms of its demand market, and that's related to its use in NdFeB magnets in electric vehicle motors. Right, and because of that, the supply and demand balance of all of the other elements will sit within that supply chain. And there's different sort of narratives we can focus on to see how could future supply impact this. Recycling will have a very key role to play once that supply chain is built up, but it's still a relatively small market. So recycling can focus in on specific rare earths without dealing with the whole suite, because you're really looking at a downstream market. So that will definitely support some of the sustainabilities of these industries longer term. But again, it is still a growing market, so primary mining is a key part of meeting that demand over the forecast period. Right, so I'll leave you there with that. Thank you for your time and enjoy the discussions today. And I look forward to speaking to you. Bye.
Okay, thank you, Camilla. On behalf of Niels, it would have been nice if Niels was here to answer a few more questions, but like he said in his presentation, if there are any issues from his presentation, we're happy to discuss. So moving on with our agenda, we've looked at why rare earths and why now. I think the issue of clean energy applications, we cannot overemphasize their importance there. But then let's come back closer to home and say, look, the market is phenomenal. The industry is growing. We're talking of between 15 to 20 billion US dollar industry within the next decade, which is exactly 9 years, in 9 years time. What is it? Why are we failing to catalyze the growth of the same industry in Southern Africa, not only South Africa? What are the barriers that are preventing the local projects, that have gone through various stages of feasibility studies, from breaking ground? And is it the geology, the complex geology of the Southern African rare earth deposits, or is it the economics of the Southern African rare earth deposits? And if it's any one of those, what can we do to, what are the key pain points that we can focus on in order to alleviate? Is it the imbalance problem where we have, most of our deposits being predominantly lanthanum and cerium oxide ores, and hence they are not economically attractive because of lower demand? Or is it a matter of scale? We should, I think, let's discuss, let's keep our minds open, let's apply our minds and try to see what are some of the issues that we can look at. Having said that, having mines, we know that having mines does not entail economic development. We still need to build capabilities. Is it human capital capabilities? Is it technological capabilities? Is it just investment capabilities that are required to build downstream capacity, the way China has done it? And of course, when we look at capabilities, we look at capacity. When we talk of Southern African mining industry, is it because we are fragmented, or is it what sort of synergies and regional collaborations do we need to build there? And of course, what is it that we need? Is it to develop the rare earth markets, not just importing a finished component because there's so much demand in renewable energy through wind generation and everything, then we import a finished magnet from China. What is it that we need to do? And that brings again to the geopolitics, okay? What is it that we can do? We know that China, at some point, controlled over 90% of the rare earths market, down to, I think right now it's almost like 63 to 65%. But 80% of all rare earths consumed in the world are processed in China. What is the role that we can play as Southern Africa, and what is it that we need to do? And last but not least, we know that rare earths, they are associated with radioactive residues and so forth. What are the environmental concerns? How do we handle that? So, ladies and gentlemen, today let's just apply our mind and let's brainstorm, not necessarily in an order, but let's try by all means to focus on some of these burning issues. And of course, we're very much open to, on the best way forward, really, what can we do going forward? If I were to say, I walk to the Minister of Minerals and Energy and say, hey, I've got a solution for the rare earths industry. What is it? How can we say it? How can we sell the whole program to industry, to academia, to investors, to everyone? So I think, Camilla, can I open the floor for discussions?
Yes, you can, Elias.
And those who cannot raise their hand, and probably you can load your questions on the chat. But it's open. Please just unmute yourself or raise your hand and let's discuss. Can I do my old habits as a lecturer at FIS, where I would just pick people randomly? I can see Petrus hand up. Please, Petrus, you have the mic.
Okay, Elias, if nobody's going to say something, let me then say something, whether it is meaningful. I don't know. It is just basically throwing a few ideas in the basket, and I'm not sure what we can make of it. Just if we look at a bit of history, the initiation of a rare earth exploitation efforts have commenced in a few other countries, and a few other countries richer than South Africa, and they have all sort of relatively promptly shut down again. Simply they could not remain profitable, and I think it is really just well, on the one hand, I suppose one could say competition from China, who is dominant, but also the volatility of the price and of rare earths. So that is one aspect. So if you were to really want to undertake rare earth production as a strategic initiative, you would really need the government to take it on as a state-owned enterprise and run it like an ESCOM and so on, and be willing to sit through times of low price and bolstering it with taxpayers' money without sort of going bankrupt. And I'm sure that in this country there won't be an appetite at this time to take on another state-owned enterprise. So I think we can forget about that one. One could then think, would regional governments, be able to actually come together to do it regionally as a strategic undertaking, where maybe the resources are located in one place, but the refining is done in another, or that resources from various countries are pulled together and shipped to a central refining location. So that would need like international cross-border kind of understanding and mutual collaboration. So everybody would need to see the benefit of doing that, and but then to sort out how does everybody mutually sort of benefit from that. You can imagine it's quite a difficult thing to do. And then this, basically universally in the world, most countries are sitting just with a plain lack of resources. It's world-class resources of rare earths are just not easy to come by. It's we do have resources, but they tend to be small. There are resources in other parts of the world that are just of the wrong type of mineralogy. It's sort of like silicates and so on. So there are technical reasons also why things are not getting off the ground in other parts of the world. It's just in many instances purely for lack of suitably sized resources. Let me just park there for a moment, give somebody else a chance.
Okay, thanks, Petras. So I've been taking notes. Let me just recap a few things. I understand the challenges that involves the profitability or price volatility of rare earths. And I think the Chinese government there, in as much as I'm a big fan of that developmental model, I think they are bullying everyone from, I know the mountain pass in Australia, in California, closed because the prices had tanked, But one thing that I liked about your suggestion is the issue of strategic initiatives. Not necessarily an ESCOM kind of thing where money disappears left, right, and center, but where actually the respective respective governments can come in and cushion producers when the prices are down. And I think if we take that as a strategic resources, we can build capacity through that. And of course, the regional initiatives, I think when we look at the economies of scale, this is also one of the biggest challenges, because we've got very high grade resources, but the tonnages are low, and then the costs associated with those processes can also be challenging. So I think with that, maybe the next question is, how can we take the first step going forward? Which I think along the way, I'm sure I will be able to answer as we go along. And I'll take another hand. I saw Stembiso Mkize. Stembiso.
Good day, everyone.
If you can put on a video so that we can see you for 2 minutes.
Oh, no, my background is not so pretty.
Okay, don't worry, don't worry. Let's not mess things up.
Yes, just before I start, a bit of introduction. Stembiso just completed his master's, and I was actually specializing on leaching rare earth elements at UCT. But before that, we also looked at characterization based on some ores which were available. So they were mainly ion adsorption clays, and that's exactly where I wanna sort of tackle this problem. The first point I want to make is South Africa as a country, we actually started extracting rare earth elements way before a lot of people actually got into them, which was from the Steenskapskraal mine in Northern Cape, where it was a byproduct from the thorium and uranium operation. So rare earth elements are not new to us per se. It's just that now, you know, the whole boom and the ease of extracting them, sort of, we couldn't catch up to that as yet. And the main reason for that was because of, obviously, the radioactive ores which we have, as opposed to other type of alternative ores, such as those clays, which are quite less radioactive. And in fact, it's quite easy to extract rare earth elements from them. Not only that, even though their total grade is a bit low, but they seem to be or be enriched more on the heavier rare earth elements, which of course gonna be the next, you know, boom when you look at the whole rare earth elements series. So looking at our current problems now, it's not just the resources also. I think the main concern here is the environmental concerns, which even from those less radioactive ores, we still have an issue of they seem to be mostly accumulated on the water table, which will pose a really, really serious problem, because then whichever way we might try to extract them, we risk contaminating the water table itself or the groundwater. And that's something which we don't like. And so even though we moved away from the radioactive resources or reserves or ores, we just can't seem to get a viable resource where we can extract them quite efficiently, sustainably, without actually damaging the environment. That's the main point I wanted to make. That it's just that one sort of aspect which seems to be giving us a headache right now, because we've seen that to actually extract them and process them and even to separate them into their own individual elements, it's not really a difficult process. Apart from that, it might be a bit costly, but it's not really the bottleneck. Right now, the bottleneck seems to be on the environmental side. Thank you.
Thank you, Stembiso. Thanks for the insight. I picked up one or two, the complexity of our ores, particularly in characterization, and then of course the environmental challenges. And I always want to ask to say, is there, I always believe that if we identify a challenge, the next thing that we need to identify, that we naturally identify is a solution. Okay, now that we know about the challenges, is there any best available technologies that we can adopt, or, I'm just throwing it out there, as part of this thinking process. We know now we have got a problem. What is it that we can do? I don't expect the answers now, and I wish.
I actually wanted to propose sort of something. Well, it was still something which we were exploring, where we wanted to adopt a sort of in situ leaching approach, where we avoid the first sort of stage of any extraction, which is the mineral processing side. But even that, it's just that one minor challenge of how do you avoid to, not sort of disturb the water table and just sort of try to target certain layers. I think there will be sort of one way in which we can try to minimize the environmental issues around this whole extraction of rare earth elements.
Thanks, Debbie. So I think that's the whole purpose. I think let's continue to apply our minds, and with the opportunities like this, I'm sure we can really eventually, make a breakthrough. Okay, I'll have Anthony. Is it Anthony or Sam Sperring? Thanks.
Thanks very much. On the last 6 years, I've spent 4 in Western Australia at the WA School of Mines, and the last 2, I'm at the China University of Mining and Technology. And clearly, battery minerals are very, very critical in that area. One of the problems that South Africa has, which I think it can overcome, is that it is furthest away from all the large markets, being America, Europe, Asia. And I think that the first thing that it's got to do is to realize that it can't work in isolation and actually form strategic partners with one of those 3 blocks. The US, Europe, Europe I have concerns about because it's not an economic powerhouse. It's not a unified powerhouse. So I think the decision is basically North America or Asia, Australia. And that's going to be critical, in my opinion, to get anything done, because that's where the markets are going to be. That's where the money is for all these developments and things like that. I don't think it can be done in isolation. Australia's probably got some of the world's largest lithium resources, and already quite a few of them actually fell off the sort of precipice because they didn't have supply arrangements in, and as someone said, the prices are very volatile at the moment. So I really do think that the key is going to be finding that strategic partner, a government or a big mining company or something, to help with that supply chain, because I also believe that we should have learned from our diamond and gold industry, where we had no downstream significant manufacturing of jewelry or anything else like that, that just to be a miner of products isn't as beneficial as it could be. And I think that, you know, finding that right partner is going to be really a very, very important thing, probably the most important thing before there's a start. Thanks very much.
Thanks, Sam. I think you have touched one of the key aspects that we also need to look at, the issue of strategic partnerships. And I always say we should never try to reinvent the wheel. I think we should, your presence in China as well, can we use you for economic espionage? You know, get as much information for us, how the Chinese got it right, where they got it wrong, how we can, you know, I'm just joking. But I'm just saying, you know, it's very important to learn from the front runners and avoid mistakes that they've made, and we can quickly catch up. But the issue of strategic partnerships, you know, towards value chain optimization, for example, what would it take to bring Hitachi to come and manufacture magnets here, and then it catalyzes other industries as well around the magnets. Thanks, Sam, for that. John, I see your hand up. Then after that, I'll come to Eddie. John. Is John still online, Camilla? Oh, I've lost him.
Yes, John is online, but he is on mute as well, but we can't seem to hear him. I'll just type him a message in the chat.
Okay. Hi, John, you're on mute.
I think carry on with the next question, and we'll try and sort out John's issue.
Okay, sure. Eddie, a brief introduction about yourself, and before you proceed, please.
Hello. Hello, can you hear me?
Yes, we can hear you, Eddie.
Yes, this is Eddie Miro. I'm currently a master's research student at University of Cape Town, doing my research in hydrometallurgical processing of rare earth elements. To be more specific, I'm using one specific ore that has been used previously in China, that is the iron adsorption clays. But even with the research that I'm doing and the literature that I've read, there's one constant problem, that the research is still limited. it's one constant that has gaps. You see gaps at every stage of the chain. There isn't enough research out there that has filled the gaps that we actually, there are very many questions. Even with the research that I'm doing, I have to add value until I get a product that can be a finished product, more like a magnet. But even at the start of the value chain, just linking out the rare earth from the ion adsorption clays, there are very many gaps that haven't yet been answered. So is there like an intentional fund to fill the gap of research development? Because there is need for a solution to actually have a better processing method of rare earth and how to separate the individual rare earth. But there is still a lot to develop, especially in terms of reactors and what to exactly use. For example, I'm trying to develop a reactor that can actually separate at the linking stage. But it's like we are limited with a funding problem of solving the research that can help us actually have a downstream process that can give us the finished products that we need, more like the magnets. So I would think that the solution would be, prior to the mining, there should be another that is intentionally made for research in rare earth elements and how to basically process it, because every ore presents a different separation, a different geological characteristic that has to be dealt with differently. And how China got it right is because they're using a different ore that is similar to some of the clays or some of the rocks that we have in South Africa, but it's still different. Some of them are radioactive, others are not radioactive. And there is a constant need for research in the development of the mining industry for rare earth elements in South Africa. So I would think this would help us better if we move the research route and alongside with the mining of the rare earth elements. Thank you.
Okay. No, I think thanks, Eddie. I think your point really talks to the to the issue on the agenda of technological capabilities, because without knowledge we cannot find solutions. And I think unfortunately rare earths has not been the mainstream of funded research in South Africa. And I think the same talks to a point on chat by Hein Muller, okay, which says what type of research is being done in South Africa on rare earths, either in minerals processing, extraction, magnets, batteries, shape memory alloys, and other uses. Where is it being done? Is it Mintek, CSR, specific universities? Who is funding it? Okay, so I think I'll probably try to just answer a little bit on what Hein has said on behalf of Mintek. I'm not trying to blow a trumpet, neither am I trying to use this opportunity to market ourselves. We have a lot of research that is ongoing from the primary processing, you know, from flotation, from mineral processing, that is funded through a state grant, that is through the Department of Minerals and Energy, towards the processing of rare earths as a strategic program. But again, the scale is not that much. We have developed processes to, you know, pre-treat complex ores like the one you can get in Zandkop's Drift, using our PyEarth technology, which is a carbothermic DCAC furnace process. We've got the hydrometallurgy division that is conducting research on separation of rare earths into various, you know, intermediate components. We've got the advanced materials that is also conducting research on the fabrication of some of these magnets and some of these high value alloys. So there is a little bit of research going on, and unfortunately it's not enough, because I think we need to build a critical mass to say, what is it that we need to do and how do we optimize the knowledge generation and also the knowledge contextualization at each and every value chain, which is exactly why we're having this conversation. And I wish we could have, you know, this conversation is so many times within a year, not just once or twice, so that we can really, brainstorm and come up with a, with a unified position to say, this is what we need, these are the challenges, then this is the way forward. Thanks, Eddie, and thanks, Hein, for raising that issue. Unfortunately, the research in rare earths is still coming up. It hasn't been as big as the platinum or titanium or the steel industry. Even globally, you don't get that scale. It has always been a niche area, but South Africa is trying to do a lot. Yes, and John, you're back.
Can you hear me yet?
Yes, please.
Can you hear me?
Yes, now we can hear you, John.
Okay. I wanted to bring up 2 points. One mentioned by Tim Biso on radioactivity, and the other one by Anthony. First of all, the radioactivity issue. Virtually all of these rare earth ores have uranium and thorium in them, but in the ground, they are insoluble. They are usually bound quite tightly, mineralogically, with the rest of the mineral. Monazite, which is the most common, is a thorium ore, but carries significant quantities of uranium. In South Africa, and I think most Southern African countries, anyone operating with those sort of ores needs regulatory approval. That often puts people off, but it doesn't need to. It requires really cooperation from the relevant government department to facilitate that. And at the production level, it's more on occupational health issues rather than on the environmental issues. The environmental issues only come once you start processing the ore and separating the uranium and thorium from the rare earth components. And that really brings me to Anthony's point. South Africa has been too much an exporter of minerals. But that is not where the value is in the chain. The value is in the processing. And I think, Mr. Chairman, coming back to a point you made about centralized rare earth processing, the only way this will work in this country is with some centralized processing in Southern Africa, not of the mining, but the processing part. And please don't mention Eskom. That's a very bad example of a state-owned enterprise. There won't be a better model than that.
I know.
But I think centralized processing and exporting of sort of semi-finished or finished rare earth concentrates, that is where the value is going to come in. For too many years, we've been exporting raw minerals. There's no value in that at all. The value sits obviously in the purchaser of the ore and the downstream processing. Now, from my experience in the rare earths field, the bulk of rare earths deposits in this part of the world tend to be cerium and lanthanum rich, although I believe there are some heavy rare earth deposits. So probably one of the first steps of this is to make sure that somebody, either the Geological Society or the Institute of Mining Metallurgy, looks at the distribution of all of these deposits to decide if you're going to have a central processing plant, where would you target, which deposits would you target? I know the heavy minerals industry, which has been running for 30 or 40 years, has produced vast quantities of tailings, much of which are stockpiled, and much of which contain reasonable quantities of rare earths. So, to summarize my 2 points, stop exporting minerals, go to the centralized facility, leave the processing with the mining companies, and don't fuss with the radioactivity. It's manageable. I know from personal experience, I ran a monazite plant. It is manageable. The regulatory aspects of radioactivity will be associated with the central processing facility, not the mine. Thank you, Elias.
Thank you, John. I think it's very encouraging to say some of the things that we perceive as challenges probably are just minor impediments that we can easily overcome.
Yes.
Yes, I think it's very important. I think one thing again that keeps coming up, the issue of regional synergies when we talk of centralized facilities. And I think I see Michelle's hand is up. I would like to give Michelle a chance, please, Michelle.
Yes, thank you, Elias. My 5 cents that I can add is I see some of the people in the chat mentioned that collaboration is necessary. We cannot just operate in isolation like we are currently, and it's quite a big problem. There are so many companies doing little bits and pieces in isolation, but there's no connection between the two. There's no common drive. And I see Russell in the chat also mentioned that the USA is resuming rare earths production, but as a footnote to that, the USA did make that a strategic direction that they are going into with the backing of the government of millions of US dollars. Canada did the same. So I believe if we as a common South Africa within the research entities can have one common goal with, and this is a very strong condition that's needed, is strong backing from the government, that not just with funding, that's obviously very necessary, but in terms of support to put us into touch with all the relevant people that are required so that we can jointly move this forward. One person is not going to move the needle. We have to, as a collective, move this forward.
Thank you, Michelle. I think I see there's someone in the chat. I'll get to you, Duduzile. Mr. Martin, can I pick on you? Can I bully you, Mr. Martin? Can you give us your view on the challenges that you are facing? He's one of our clients. Sid Martin. Okay, I'll send him a chat directly. Okay, Duduzile, over to you.
Thank you so much. You know, my comment is in line with what Michelle just mentioned now with respect to the issue of collaboration and most importantly, visibility, because I'm currently doing my PhD with the supervision from Prof. Wagner, Nikki Wagner. So we're establishing rare earths that can be mineable from coal reserves, for example. So whenever I go to settings where I introduce my research, a lot of people are not really aware what rare earths are, and it should be the opposite because we are using materials that are primarily from rare earths. So what I'm driving towards is, I think, in as much as we have to be a collective unit and collaborate, there has to be some element of visibility in a sense that everybody or most people are aware of the gold industry, the platinum industry, notwithstanding the fact that it's been in our country, or the operation thereof has been in operation for years. But I think people become more aware of a product if more people are introduced to it. So probably some things to assist in making sure that the rare earth industry is put in the map, and in a way soliciting funding is to make it more visible.
Thanks, Duduzile. I think you have said one of the key issues that have always been advancing. The problem with rare earths is not a mainstream commodity. Okay, so you find that you won't find many experts. Hence, we struggle to build critical mass. But just to reassure you, I think this kind of discussions that we're having is actually the right step. You know, the few steps towards what we want to achieve. Bring visibility. Right now, people are talking about 100 megawatt threshold in terms of renewable energy. We're talking of wind energy. We're talking of electric vehicles. As long as we don't make enough noise to say, without the rare earths, forget about all those ambitions, we'll continue to fall back. And the other thing, again, is the problem with rare earths is they are also stubborn, metals. Their chemistry is just complicated So I think it does really put people off. Okay. There was a comment on, I think from Hein as well. It says the Department of Science and Innovation has a program named the Advanced Materials Initiative. It is based on 4 developmental networks: 1, ferrous metals, light materials, mostly titanium, precious metals, which are PGMs, and nuclear materials. Would be good fit to, it would be good to fit the rare earth elements in the army too. I think, can I take this, Hein, as a personal challenge that we can drive from Mintech side, me and my colleagues at Mintech, where we can actually try to explore and see how far we can surgically, direct funding within all the respective institutions so that we can have impact in that area. Thanks for the information. We will pursue that as well. Did I miss? Is there anyone else where any comment from someone else? I think there was a comment earlier on. What exactly would Southern Africa want from the available rare earth deposits? I think John tried to articulate that exporting mineral concentrates is suicidal. We've seen that with the PGMs, we've seen that with the gold. We're home to some of the deepest gold mines in the world, but what do we have to show for it? It's because there's no downstream capacity, there's no value chain optimization. So we really want to build a knowledge-based economy driving the future industry of the, of the rare earths. I think for me, that's what would excite me. But again, I think we've got to start somewhere, but I think the key aspect is downstream processing. But before we achieve downstream processes, we have to be able to understand the value chain. Okay, as to say, is there a plan, is there a vision? I think the answer is yes, and the answer is no as well, because I think what we're doing right now is the right step towards achieving the full value optimization of within the rare earth industry. I see Petra's hand is up as well. Petras, back to you.
Elias, we've also got Sydney Martin's hand up. So you can maybe take that after.
Yes, okay. Petras, then after that, so we have Sydney.
Okay, of course, when we think that we've got a feasible way of exploiting our resources, that we have a plan in place that addresses the technical issues, the environmental and so on, we need to get the message out there to the extent that it convinces a mining company or some entrepreneur to actually step forward and act as the operator and take on the mineral rights of that, and spend the money to put a plant up and actually operate it as a business then. It's no use we have all the answers, but we're not convincing anybody to actually make an investment and run it as a business.
Thanks, Petras. I think I totally agree with you there. And within Mintech, we now have this mantra that whatever we do, we need to do what is called co-creation and co-development. So, which means we identify problems, we find solutions with industrial partners. So I think that will again talk to one of the guests in the chat, Mr. Sydney. Introduce yourself and then
All right, thank you all. Dr. Elias, can you hear us?
Yes, I can hear you, Mr. Martin.
All right, thank you very much. My name is Mr. Sydney Martin. I'm representing a company called Broadmind Mining, and we're based out in Namibia. Just to let you know, we have been doing business with Mintech for a number of years now. And they've been very critical in the issues that have been raised today from the panel. Issue of extractability, issue of centralized processing. We've been on this journey with Mintech for a while. So thank you for the opportunity that you've given us to maybe just comment. It also goes on to what Petrus just mentioned now, that as businesses, which is us, what role we need to be playing in terms of this process and the value chain. The challenges that we face obviously as a business, many people mentioned the issue of thorium, radioactivity materials. So we faced that directly when we were just trying to export some samples to Mintech for processing. So we had to engage our radioactive authority here in Namibia for them to be able to give us an analysis of the radioactive levels in our deposits and if we'll be able to export our samples. We did get a detailed report from them, and we were lucky that the quantities we were exporting at that time for sampling were below the threshold. So, but it was a process that we had to go through as a business, which we had not anticipated. So now obviously it's pleasing for us to now hear people on the panel talking about this aspect. So it's something that as a business we need to continue to consider. And also just to let you know that Namibia is signed up to the Paris Agreement on climate change. So the Environmental Commission here is also very stringent with regards to how we protect the environment and compliance with especially the ESGs. So as we progress with our projects, ESGs will always remain a critical component of the project. So as part of the ESG process, obviously we had to get an environmental impact assessment done. It's a costly and lengthy exercise, but has to be done. And here it always expires after every three years. So every 3 years you have to keep renewing it. So again, as a business, we need to make sure that we continue to comply with the requirements of the ESGs. One key thing that has been raised as well that is very critical for us as a business is this issue that has been raised of the centralized processing facility. That is something that is also very close to our heart. And I mean, it's a discussion that will continue to be taken further. We've had these discussions with Mintech previously. So it's something that's also very close to our hearts. And I'm glad that even for you guys as the technocrats are also bringing this up. Because for us as businesses, it's about also how far down the value chain can you control the process. So it's very pleasing to hear that people are sharing the same sentiments with us there. I think for now, I'll just end there, and then any other questions, we can continue.
Thank you, Sydney. So just a recap, you believe that these kind of engagements are most likely to assist us to come up with a more viable solution to the value, chain optimization of the rare earths industry. Would we have an appetite for more of these engagements as an industry end user, or are we really addressing some of the key issues? I just need that validation.
Is that directly to us?
Yes, as an end user. Do you think this? Yes. Okay.
Yes, definitely. These engagements are very crucial. I think that's why we've even taken the time to participate, because it then gives us that broader aspect of what we're involved in, what are the issues, what is the industry globally looking at, and helps also guide us as a business of how we move forward.
Thank you, Sydney. Is there anyone else with a hand up? I see John, you still have a hand up, or it was from the previous, and Stevenson.
Can you hear me?
Yes, we can hear you, John.
I think we're talking about centralized facilities, and one of the topics, of course, is geopolitics. Many Western countries are very anxious about the supply of rare earths being in the hands of one country. Now, it was mentioned, I think, a little bit earlier in the discussion that Canada and the US are looking at doing something themselves. Now, there is an opportunity there for South Africa. If those Western countries would view South Africa as a way of diluting the impact of China on this supply chain, we might be able to attract investment to our central processing facility from various Western countries. So there's a possible investment opportunity there driven by geopolitics. Thanks.
Thanks, John. I think for for now, and I think within the near future, even the long term, I think it's safe to say that the geopolitics is working in our favor, and we really should take advantage of that and attract as much investment as possible. The way Malaysia has done with acetic liners, they've really built up a sophisticated concentration plant there. But for us, we're saying we want to go further than that. Thanks, John, for the heads up. And is there any hand, Sydney? Your hand is up. Was it from the previous? Do you want to add something more? Okay. And Stempy, so your hand is still up. Do you want to add something?
Yes, I did actually. While we are still talking on the opportunities and the value chain, I think we understand why we have less of investment and funding, especially on the research and the business side. It's exactly that. I mean, there's a limited view on the value chain of these rare earth elements, but I think it's limited because of we haven't exposed sort of the downstream benefits of these rare earth elements. And one in particular, which is a good example, there was an organization that is expanding the use of wind turbines as the supplier of electricity. And actually they have a project which is, I'm not sure if it has started, but it's supposed to be underway in the Karoo, a big expansion of these wind turbines. And there's also a future project which is being looked at to put, those wind turbines just, on the coast, if there are sort of land concerns, which, it's understandable. So by just looking at that, if there's an expansion of wind turbines, that means there's going to be a high demand of magnets. High demand of magnets means a high demand of rare earth elements. So there is some sort of something which we can look at where we can benefit by just looking at this one particular value chain. Thank you.
Thanks, Stempy. So I think you are very right. I can't remember the figures offhand, but one of my colleagues, Itumeleng, she's always throwing around those figures from the MRI, the targets in terms of wind energy, and then she always quantifies to say how much in terms of per kg. But I'll look around the figures from here, and then I can circulate. And I have Hamen Otterdam.
Yes. Can you hear me?
Yes, we can hear you, Hamen.
Thank you. I'm from Europe. I just wanted to put in a little word from Europe. There were some comments on geopolitics and about finding partners, and I think that's absolutely right. South Africa or Southern Africa at the moment has trouble actually keeping their chromium and manganese monopoly or dominance that they had. I asked about vision, and to me, the US and Asia were seen as powerhouses. Europe is one of the biggest economic blocs in the world. It's more divided than it seems, but less at the same time. And Europe is the only bloc that managed to put up within a couple of years a massive battery industry out of nothing. The magnets and the rare earths play a massive role in that. So I do think that the fastest development would be cooperate with one of the powerhouses and then see to get the best deal that within 10 years time, latest, then there's less export and you have your own downstream business set up. But you can't develop mining, primary processing, secondary processing, and downstream industry within 2 years. I don't think it's feasible, but I think you should find the best trade-off in development, exporting, and restricting exports, which is actually, I think you should do for every mineral you have. That's, at least, I think that's a vision. In 10 years, we want to have a downstream industry, and not say it would be great if we had one. That's just dreaming. Thank you.
Thank you, Amen. I think you have really said it the way. The issue is we are looking at how we can optimize the value chain. And unfortunately, or fortunately, we are lucky for the resources, but we don't have the capabilities for downstream. So I think we can calibrate each and every intervention along the value chain. Thanks for that. And I think coming back again to the issue of synergies, not just regional synergies, but global synergies as well. I think it's something that is very important for us to consider. Okay, I'll take another question. I think we're almost, how are we doing on time, Camilla?
We are 5 minutes over time, but I think we can continue until 3:15.
Okay. And can we, it was supposed to be you, eh?
Yes, but you got excited.
I'm sorry, I'm just looking at the agenda now. Okay, you take over from there, from here. Okay. So any questions, guys? Any more questions before I hand you over to Mukhle? Mukhle, I think you can take over from there, and you can
I will just say a few words, Elias, but then you have to continue because I believe that the rest of the program you're supposed to take care of that. You have to is the introduction of the conference. So, but let me just say a few words before you take over again. It won't be more than 5 minutes. So, of course, I mean, if you look at this, primary processing is quite key in the near future for meeting demand, and particularly for us in Southern Africa to even establish then the industry for its processing. But I'm a bit futuristic in my thinking. So, recycling will be quite key in years to come, even for us here in Southern Africa. Europe is developing expertise. They're quite very fast. They have lots of support, of course, from Brussels, from the government. And also what we don't have here, it looks like it's mainly the technical people and business guys. We also need to get government. The DMRE should be featuring more here. So it's something I'll take up personally, because we cannot be, Michelle did raise this point that it's important that we get support from government. We can talk all these wonderful things, but if there's no will from government, we're not going to go too far. So for future engagements, government will have to be on board. And then also talking about then the circularity, which becomes quite important. It's particularly important, for example, for the heavy rare earth elements. If you look at the balance problem, you're looking at something like dysprosium, where about 20 years ago, the magnets, they will have about 5% of this component. But with the advances in technology, the amounts now are as low as 1%. So which means once there's enough end-of-life rare earths to then recover this dysprosium, it will be many folds more that they'll be able to recover from a small percentage, but to make many more batteries or many more magnet materials, because the technologies are improving and the amounts of those elements that are required are becoming lower. And again, it talks a little bit to a comment that was made by, I believe, by Eddie, talking about that there are so many gaps that are there. It is the truth. There are many gaps in primary processing. There are also many gaps in secondary processing. That's why the entire EU, they are looking at projects, I mean, including, again, the guys that left, the BRICS guys, including the Brexit guys too, including the UK. They're working extensively on this, and they're working extensively as the EU, utilizing, again, the strengths of each country, of each institution, something, again, Michelle raised earlier on that we are not doing here in South Africa and in Southern Africa and beyond. So there are chances there for us, opportunities there for us, as far as then maximizing on the technological capabilities and developing those. And if you look at China, I mean, their VRA's 2025 strategy, that states is a very bold one. And of course, China will achieve it because they have a will to do so. No rare earths are to be exported unless they're in high value form. And in South Africa, we're always preaching beneficiation. And again, this is even known by our minister, by government, but nothing is really happening. So we need to be very bold. And we also have to have a vision, as our friend from the EU has mentioned, so that we can achieve all of this. So on my side, that's about it. And of course, just one last one, Petra did mention the technical shortcomings regarding some of the very complex resources around the globe. Yes, I fully agree with you, Petras, and that's why there's extensive research being undertaken so that we can overcome those technical challenges and so that those resources can be processed and become reserves. So on my side, that's it. Many thanks.
Thanks, Mukhle. I think we're a little bit over time. Camilla, can you just pull up our conference? Want just to introduce people to our conference. So, ladies and gentlemen, today's interaction is just a prelude to the conference that we're organizing in October. So that will be on the 18th and 19th of October 2021. It's an online event. You are all invited. So we have about 12 papers. 6 will go directly into the conference proceedings. 6 have been nominated to go into the journal. So we'll have a special journal as well. The whole idea, the whole objective of this event, today's event, and the conference as well, is to debate and discuss and apply our minds and say, what is it that we need to do going forward? So we are looking forward to have you at the RAISE conference, which is organized by Camilla and team. They're the brains behind, who are just assisting, and we really look forward to having this engagement again. And I think with that, if there are no other issues, we can close. Please, if something comes up, you have that moment when you're in the shower, when you're driving, please drop us an email. You can contact me, or you can contact Butle or anyone who is in committee, Camilla and team, so that we can continue to engage. We don't want this to be a once-off event. So I think for me, Camilla, anything else from your side? That's all from me for today. I think it was a very fruitful discussion. Thanks for organizing this.
Thank you, Elias. And just a note to everyone who has attended this open discussion today, that if you register for the conference, you can get 20% discount on your registration. So please make contact with me, visit our website to find out more information about the conference.
Thanks, Camilla. All right, thanks, guys. Thanks for attending. And it was really, really nice to engage with you guys. So we look forward to seeing you on the 18th and 19th of October when we're having the conference.
Thank you, Elias. Thanks, everybody.
Thanks. Hello. Bye-bye.